Okay, everyone, it's time for another episode of the Michael Shermer Show. I'm your host, Michael Shermer. I'm the publisher of, as you know, Skeptic magazine. Here's our latest issue on nationalism matters, keeping with our theme for last year on race matters, abortion matters, and trans matters, taking on non-controversial subjects. In 2023, our first issue is on money matters, economics and money and capitalism and all that good stuff. So we're branching out, applying skepticism to lots of areas. If you support our work, you can go to skeptic.com and subscribe, or you can go to skeptic.com/donate and support the 501c3 nonprofit Skeptic Society. And we appreciate your support, which also supports this podcast. My guest today is Heinrich Päs, a professor of theoretical physics at TU Dortmund University in Germany. He has held positions at Vanderbilt University, the University of Alabama, and the University of Hawai'i. Oh, wow, that's cool. I read something in your book, Heinrich, about surfing at midnight. Okay, we have to come back to that later in the conversation. And he's conducted research visits at CERN and Fermilab. He lives in Bremen, Germany, where I was just over Thanksgiving break was there. His new book, here it is, The One, How an Ancient Idea Holds the Future of Physics. Love that cover. Very nice. Hi, Heinrich. Nice to see you. Thanks for coming on to talk to me.
Hi, thanks for having me.
All right. So before we get into the meat of the book, give us a little bit of background. You've obviously been around the world. Where were you born and raised, and what were some of the influences in your education and career choices?
Yeah, I'm actually from Bremen, and I grew up here and went to school, and I early on was fascinated by physics and philosophy, and also by ancient thought. I learned some ancient Greek and Latin in high school, and early on I thought that these ancient philosophers had some ideas which are similar to what physicists think about, and so these ideas drove me for a long time, and somehow evolved into what I write about in my book. After that, I studied in Heidelberg, got a PhD for research at the Max Planck Institute on process in nuclear physics related to properties of the neutrino, a very fascinating elementary particle. Then I had postdoc positions at Vanderbilt University. I returned to Germany for 3 years to Würzburg University, went to Hawaii, which was fantastic, for 2 years, became an assistant professor in Alabama, and soon after a full professor in Germany. And there I am now, still thinking about the universe.
You've come full cycle. Yes, I like that. All right. So the subtitle of your book, again, here's the cover. How an Ancient Idea Holds the Future of Physics. You started at the beginning with that physics is stuck, or there's a problem. What's the problem with physics? What is your book addressing?
Well, the problem is the way how we do physics, especially the fundamental physics, where we really dig down and want to understand the core of things. Usually we think in a way like our daily environment, the things we are used to in our daily lives, like chairs and tables and beer bottles. They are made out of atoms, and then the atoms are made out of even smaller things, such as quarks and electrons. And maybe at the end, these quarks and electrons, they may be oscillation patterns of little strings or whatever. So the point is, we think we get closer to the foundation of things when we go to smaller things and build up everything out of smaller things. And this is a philosophy which was very successful for many years, and I was totally convinced about it. But then two things somehow changed my mind. First, a better understanding of what quantum mechanics means, and then problems we are encountering with this way of doing physics, like very unlikely coincidences we encounter in particle physics and cosmology, And uh, yeah, such things are also the problems like to quantize gravity. It's yeah, something like that. Yeah.
So, but what you've described is sort of the reductionism model of science or physics, which is pretty accurate for the most part, right? I mean, things really are made of smaller things, and smaller things still smaller too. And the word atom literally means unable to cut, right? You've hit the rock bottom, you can't divide it anymore. And so you mentioned electrons, protons, neutrons, and then those are made up of quarks, and quarks are made up of whatever. And ultimately, you get down to these strings, maybe, and that's what, pure energy. So there is no bottom there. It's just at some point, it's just energy.
No, no. The usual thought is that there is a bottom. That in particle physics, people think of quarks and electrons as really fundamental. That they are point-like particles, and you can't divide them anymore. If they are essentially strings, then they are not point-like particles, but they are one-dimensional. But still, they are fundamental. So this is the typical thing, the typical line of thought. It is very accurate. It works perfectly fine. The best theories we have in science work that way. But if we take quantum mechanics serious, then we have this phenomenon of entanglement. Entanglement means if we have a system composed of subsystems, like an atom composed of elementary particles, then we can perfectly know the total system, the whole, but we don't know anything about the subsystems. So that means, the entire system is in a perfectly well-defined state, but the subsystems aren't. And it turns out when we want to know what the subsystems, in which state they are, what they really are, then we have to destroy the whole. And we can do that by measuring it, but that means we somehow couple it to the rest of the universe, and this only delocalizes this connection. It really doesn't cut the system apart. So according to quantum mechanics, we can't really we can't really how you say it, dissociate or cut open a complete system without losing its essential information. Decomposing was the word I was looking for.
Decomposing. Really in other words, there's a limitation to reductionism for explaining the nature of reality. Maybe you could explain the two-slit experiment. It's probably the most famous thing people have heard of. That maybe captures the concept of entanglement.
Yeah, well, the two-slit experiment is it's more about a superposition. Actually, superposition is very similar to entanglement, but it's not exactly the same as entanglement. In the two-slit experiment, you have particles which are shot on a screen with two slits on it, and then you look what you see behind the screen, and what you see behind the screen corresponds to particles going through two slits or waves going through slits. So you see a superposition of wave patterns behind this screen with two slits, and if you think in terms of particles, the particle goes either to the left through the left slit or through the right slit, but it can't go through both slits at the same time. But the wave pattern behind the screen demonstrates that somehow the information goes through both slits. So this means, you can think of the particle being in a superposition of going through the left slit and the right slit, and so
somehow they're interacting, but not in this world or in some other dimension, or I'm not even sure how to say it.
Well, somehow, if you think in terms of particles, you would think this particle goes either to one slit or the other. But somehow it feels both slits. So in my opinion, this demonstrates that this thought of particles doesn't work here. You have to think in terms of waves to really describe this experiment. And you can't really decompose the wave into particles.
Right. So this is the wave particle duality of quantum physics. And it suggests that if you ask, well, which way is it really? That's the wrong question. It depends on the experimental apparatus or the setup that you're using to measure it that determines what it really is.
Right. So the wave particle dualism or complementarity, as Niels Bohr called it means that you can describe things either as particles which have a specific location or as waves which have a defined wavelength and momentum. So the question is, what is behind these two things? And Niels Bohr and his school of thought, the people who adhered to the Copenhagen interpretation of quantum mechanics, they didn't really adopt any reality behind these two pictures. They thought you see either one or the other in an experiment, and this is all. And quantum mechanics describes only our knowledge about nature, but not really knowledge itself. So the quantum mechanical wave function, which describes both these pictures, waves with defined wavelengths and particles with defined positions, this wasn't a concept describing nature for Bohr and his friends, but just a way to describe our knowledge about nature. And for some time this looked fine. It looked a little weird maybe, but it looked fine since nobody really knew what happened if we measure a quantum system or compare a quantum system. And then this new effect came in called decoherence. And decoherence nicely describes what happens if I have a quantum system described by a wave function and I let it interact with an environment. And this environment is not perfectly known to an observer, since the environment in last consequence is the entire universe, and nobody knows the entire universe. So since the observer doesn't know this huge, immense environment completely, he has to somehow average over it. And this, in effect, leads to our original wave function, leads to the effect that our original wave function gets localized to something which looks like a particle, or localized towards a specific wavelength to something which looks like a wave in our usual space. And I think this effect is a strong argument for taking this wave function serious as a model for nature and not just as a model for our knowledge about nature.
This is an interesting point about whether these models. Well, this is what Hawking and Leonard Mlodinow called the model-dependent realism, I think. The realism you think you're studying very much depends on the model you're using, which is ultimately limited by human cognition. None of us are deities. We're not omniscient. So anything model we come up with is going to be limited. And so we can only know so much, right? And so is that what you're getting at with, kind of exploring these different ways of interpreting reality?
Well, the point is the quantum mechanical wave function, we can't observe it directly. And it also doesn't exist in our usual space and time. It exists in some abstract Hilbert space or some abstract mathematical space. So we can't observe it directly. So the question is, can we take it serious as reality? Or isn't it reality? Is it just a tool for us to understand physics? And for many years, this view of Bohr dominated that it's just a tool. And now more and more people think that first this attitude is a little bit unsatisfactory, and also that there are reasons to adopt it as a model for nature, as a model for reality. Since our new understanding of decoherence shows how this object, the quantum mechanical wave function, evolves into something that we can observe.
And is this related to, well, the multiverse? That's not the right word for this, right? There's multiple universes at the quantum level. So in one unit, so when the particle seems to go through the left slit or the right slit, well, it did both because there's more than one universe. There's more than one place for it. So every time the atom split or the particle split or whatever, the wave function does whatever it does, it's actually doing that in some other universe.
Yes, it's related to that. That's the idea of Hugh Everett, usually known under the name many worlds interpretation.
That's right. Yeah.
So that in a quantum measurement, you either measure the electron go through the left slit or the right slit, as you say, or if you think of Schrödinger's famous cat, which is in a superposition of being dead and alive. It's when you look at it, it's either dead or alive, but nothing in between. So Everett's idea was that both these outcomes are realized in an experiment, but in parallel realities. And these parallel realities are these many worlds of the Everett interpretation. And this is actually what comes out when you adopt this this mechanism of decoherence to a quantum system, when you couple it to this environment that the observer doesn't know completely, that these superimposed realities of electron here and electron there, or cat live and dead, they somehow get disconnected. So the superposition, the overlap between these realities is reduced, and you end up with a sum of these two realities and two observers. One observer seeing the electron going through the left slit, one observer the electron going through the right slit, or one observer seeing a live cat and one observer seeing a dead cat. So this is Everett's many worlds interpretation. But my point, or probably the most important point of my book, is that this label, many worlds interpretation, is somewhat misleading, since it describes only what happens in a measurement from the perspective of the observer, who doesn't know the entire universe. But if you look on it from a global perspective, then the whole thing is still an entangled quantum state. It's still a whole. It's not many words, it's one word, but it's a quantum word.
Right. So, and just as a technical point, when you say the observer, it doesn't have to be a sentient conscious being, right? It could be a camera, or it could just be interacting with the world in some way.
Right. It can be some apparatus which takes some record of the state of a quantum system, and which is large enough or strongly interacting enough so that it's in contact with the environment.
Yeah. So when an outsider like me looks at this and sees that you guys who do this for a living can't agree on what the right interpretation is, that tells me, well, it's either early in the science and they just haven't figured it out yet, or maybe this is the wrong approach and we need a completely different approach. I gather that's what you're doing in your new book. You're saying we need to take a completely different approach. This isn't getting us there.
Well, no, I mean, my point is that people were focusing too much on using quantum mechanics as a tool. Every physicist uses quantum mechanics as a tool. And they were not really thinking too much about what quantum mechanics really means. And this is related to the history, of course. I mean, there was this grand debate between Niels Bohr and Einstein, and Bohr said quantum mechanics is complete, and Einstein said, oh, it doesn't describe reality, so it can't be complete. And Bohr said, oh, we don't have to describe reality, we just have to describe what we know about reality. And Einstein said, no, I'm not satisfied with that. And then the Second World War came, and everybody was interested in building nuclear bombs. And after that, people studied elementary particles or superconductors or nuclear physics. And they stopped thinking about what these things really mean. And I think now we are entering a stage where we have really stubborn problems in fundamental physics, and we have to take a step back and rethink these foundations.
Right. So you start off quoting Heraclitus, from all things one, and from one, all things. I have to tell you, Heinrich, this sounds like a tweet from Deepak Chopra. What does that mean?
Yeah, well, I mean, I agree. It sounds like bullshit, right? But I also have a theory why it sounds like bullshit. Yeah, I think that from all things one is how entanglement works, and from one all things is how decoherence works. And I think that we should take this hypothesis that the most fundamental description of the universe is not a universe which is made out of many things, and these many things are made out of smaller things. So it's not a fragmented view, but the most fundamental description of the universe is the universe as one single unified thing. And that we can use this as a basis and then use decoherence, use our perspective onto this unified single thing to explain what we experience, why we see many things, and so on.
Interesting. Yes, I quoted Deepak because he's a friend. I like to give him a hard time about his tweets. But he actually means something serious about that. He calls himself a monist. Also, I'm a monist, by which I mean well, here we're usually talking about consciousness. So, or mind. And when I say I'm a monist, I mean there's just brain, and the word mind is just a word we use to describe what the brain is doing when it's processing information or whatever it's doing. But Deepak, he would agree with you. I think he'd like your book because he's a monist. He's kind of a mind monist or consciousness monist, that the one, the single thing underlying everything that ties everything together is consciousness.
Yeah, I'm not sure about it. I mean, I think probably, I mean, I'm no expert about consciousness. I'm a physicist, but from what I know about consciousness, I think it's probably something like processed information. And then the question is, for information, you usually need some storage device. You need a hard drive, or you need a USB stick where you store your information.
Yeah.
And information without storage is difficult to think of. But on the other hand, also matter in this view from quantum mechanics, where I say particles don't exist and matter is made out of particles, also matter is somewhat emergent. So I don't really know what this one is, whether it's matter or information. I think it's probably something beyond these things, since these things, matter and information, are still tied to how we experience the world and the labels we put to our experiences. And this is something which is on a more fundamental level, which we don't directly experience.
It also reminds me a little bit of Fritjof Capra's books, The Turning Point, the previous one, The Tao of Physics. I had him on the show last year. Super interesting guy. I love those books. But, there he's tying together Eastern mysticism and quantum physics as if they both discovered the same thing through different avenues. I don't know. What are your thoughts about that connection?
Well, I mean, I can't exclude that there are different avenues to somehow get information about this foundational reality. But I think the problem with religion and how religion adopted this idea of monism, especially in the Western culture. I don't know so much about the Eastern cultures, but in the Western culture is that it adopted in Christianity, for example, this concept of one and then equated it with God. But then God was not identified with the universe, but it was put into some transcendental realm. It was to put it some otherworldly beyond and thought of being opposed to the world. And then, of course, this was also for Christianity, after Christianity became a state religion in the Roman Empire, it was a question of political power. So if there is a God that exists everywhere and pervades all things, you don't need a caste of priests that serve as intermediaries. So they were quite eager to suppress any thoughts that this unifying principle, this one, could be mixed up with nature. So it should be there, opposed to nature, governing instead of being the world. And I think this basic idea, is still somehow active. Still somehow, when we talk about metaphysics can be theology, can be thoughts about God, but can also be the foundation of physics. And all proper physicists, they think that metaphysics somehow is something which is of no interest for them. It's something which is not real physics. It's just talking and isn't the real stuff. So I think these.
Is that where the line? Is that where the line "shut up and calculate" comes from?
I think so. Yeah, I think this essentially is it. Your physicists should concentrate on developing mathematical models and calculate things with these mathematical models and then compare them with experiments. But they are not supposed to think about the great things behind what the real foundation. And I think this is the heritage of the split of the unifying principle and removing it from the observable world. And my point is that we should take this principle serious again as a hypothesis for science, even if such a unifying principle, such a one, is not directly accessible in experiment. It might be a useful foundation for developing theories which then make observable predictions.
Well, one of the parts I liked about your book was the very second to the last page. Can it be wrong? I love that you actually put it right out there. Back to science. If monism is indeed a universal principle pervading and connecting the universe or the cosmos, we must ask a scientific question. Can it be wrong? And your answer is, of course it can. If monism is seen as a scientific concept again, this makes it vulnerable. Every scientific theory should make predictions that are confronted with experiment, and every theory can be replaced if there is an experimental evidence against it, or if it persistently fails to explain important facts in its range of application. If it isn't fruitful. The main message of this book is that monism is indeed fruitful for science. Monism follows straightforwardly from quantum mechanics taken seriously. It provides a philosophical framework for most recent work in quantum gravity and a new perspective needed to approach the fundamental problems in particle physics and cosmology. Okay, so let's kind of hover over that a little bit and think about that, because we are talking metaphysics and philosophy, but that's okay. I like that. To me, that's where the fun stuff is. I mean, so Deepak Chopra, Frijaf Capra may like your book, but so might a theologian. I could see a theologian going, yeah, that's what we've been saying, the one, that's God, whether it's a pantheist or a God outside the universe or something. But how would you think about that in a Newtonian mechanical universe? Because their theologians say something like, well, God is outside of space-time and reaches in to stir the particles or create the universe or make planets or whatever God does. And so maybe that's not the right way to think about a deity.
Yeah, I mean, my point is we should take this concept serious as a concept for the universe, for nature, for science, and not think of it as something which is in some otherworldly regime, which is spirit or something I can feel only when I have some whatever, some relevation or whatever. I think we should take it serious as a concept for science. This is my most important point. I mean, I don't think this concept follows from Newtonian physics, of course, since I think it's very tightly connected with this phenomenon of entanglement, and also connected with this phenomenon of decoherence, which describes how this entangled universe can become something which we can observe with our experiments, with our scientific methods. But Newton had drew some inspiration from monistic concepts himself, which I also write in my book. Many scientists had this inspiration from monistic concepts. Newton was inspired by what was the name of this British philosopher?
Locke? John Locke?
No. He was also in Cambridge. I don't get the name right now. Cudworth. He was inspired by Cudworth, and Cudworth had also had this strongly monistic theology, and Newton actually thought that this principle which unifies the universe is something which is related to gravity.
Right, as a force. I mean, so when you use these phrases like the one, or there's kind of a unifying something underneath all of this different portions or parts of reality, a field comes to mind, like an energy field or a force field or something like that. Is that what you're thinking of?
Yeah, well, I mean, of course, we know, for example, when we do particle physics, we think of particles not really as classical objects, but as excitations of quantum fields. And so field is kind of fine, but I think we think of fields still as things that exist in space and time. And I think this unifying thing is really beyond space and time, and also space and time emerge from it. So there is some research when you try to develop a quantum mechanical wave function for the universe. What you end up is an equation which is very similar to the standard equation of quantum mechanics, the Schrödinger equation, but it doesn't evolve in time. It doesn't have any time dependence. So this can be interpreted as that a quantum universe is something which is timeless. And I think this makes sense, since time is closely related to the concept of entropy, that cups fall off the table and get broken, and but you usually don't see some broken shards on the floor which cool down the environment around them and decompose to a cup and jump onto the table. So if you see that, you usually know the movie is shown in reverse, and this is entropy. So time is related closely to entropy, and entropy is something which describes a lack of information or limited knowledge about something. A cup which is intact, there we know which part of the cup has to be at which position and how it is composed. But a broken cup can be broken in many ways. And so this, if you just say the cup is broken, that we don't know in which way exactly it is broken, this describes our limited knowledge about this broken cup compared to an intact cup. And so that means entropy always increases with time. And if entropy is limited knowledge, and we really want to look at the fundamental description of the universe, which I would say is the one where we don't throw away any knowledge, where every knowledge is present, then the entropy is zero, since we have our knowledge. And if the entropy is zero, then there's also, if time is something so closely related to entropy, there's also no time. So I think it makes sense to think of this fundamental reality as timeless. And then also, if you say this fundamental reality is only one thing, space we usually think is something which relates locations of different things. Space is what tells us that one thing is left to another or so. So if there's only one thing, it doesn't make sense to talk about space. So in some sense, it's an obvious idea that if we have a fundamental reality and this fundamental reality is just one single thing, that this is a reality beyond space and time.
Well, if you've just eliminated space and time, what's left?
Yeah, well, it's this one, and as we said, we don't really know what it is. I mean,
Okay,
we don't
all
know
right.
whether it's information or matter or something in between or something beyond. But it's just this quantum mechanical object which is somehow veiled to us, which since we can't observe it directly. But this nicely fits with ideas the ancients had about this one. So, for example, the Egyptians thought about this goddess Isis, which represents the entire universe, but which was shown with a veil. So, since it couldn't be seen directly, it could be seen only in its effects.
Yeah, so let me see if I can re-articulate that. Entropy. We think of the second law of thermodynamics. Well, it's a law of nature. It just has to happen this way. Or entropy. It's almost like a force that's making things fall apart. But really, it's more like a statistical probability of things happening or not. So if you think of sand at a beach and you build a sand castle, there's only one way for the grains of sand to come together in that particular sandcastle you made. But there's a near infinite number of ways the grains of sand could be distributed in some other amorphous mass of nothingness, right? So it's really just what are the odds of the grains of sand coming together just like that, right? So this becomes kind of the intelligent design creationism argument that there are certain things in nature that could not have come about randomly through the forces because of this entropy problem. Therefore, somebody had to come in and tinker with the particles to make it come together, the equivalent of a sandcastle. It's DNA or RNA or the eye or whatever your God of the gaps argument is. Something like that, right? Would that be correct way to say it?
Yes, exactly. It's just that the orderly thing which get disconnected is highly improbable compared to the broken and chaotic things.
Yeah. So I think the purpose of life, when I try to answer that question, I did this in Heavens on Earth, is to just carve out a little niche of order in your life, because your entire life is just going to be pushing back against entropy. And it's not that there's anybody out there that's against you. It's just that there's just way more ways for things to go wrong for your life than to go well. So that's your job. You gotta eat every day. You gotta consume energy, right? You gotta work out, clean your room, make your bed, work out. Just do something to push back against entropy. There's even a group that these transhumanists are called extropians. They're against entropy, right? So it's kind of funny. But ultimately, the hands of time will get them because they'll run down. But it seems to me that the arrow of time, you just said it's tied to entropy. Things just run down. The movie, you can tell which direction the movie is rolling, unless it's a close up of a billiard table in which the balls are bouncing around. I guess there you can't really tell which direction the movie is going. But although I guess if you let it run long enough, the balls would stop rolling, or they would not stop rolling, and then you would know which direction it's going. So time, then, would you define time as just describing what entropy? It's just stuff is just moving in one direction because that's how it goes.
Yeah, I think it's at least it's very closely related.
Right. So when Einstein it talks about space-time as if it's one thing, is that what you mean, or do you think that's not the right direction to go for your one?
Yeah, I mean it's it's related. For example, Frank Wilczek, who got the Nobel Prize for work on the strong interactions in particle physics, he talked about space-time in a way that, space-time you can think of as being some kind of block where you have time and space, and then we are following some path in space-time. But in principle, if you look at this block, this entire path is there. You, at all your ages, are there along this path. And so he compared what he called the ant's view, like an ant crawling along this path, which is our conscious experience, to the God's view, to someone who looks on this entire view, on this entire block of space-time, sees this entire path that the ant crawls along. And he contrasts these two views. And in quantum mechanics, we have something similar. In quantum mechanics, we have this, what Max Tegmark, a cosmologist at MIT, calls the frog's perspective, which is the perspective of the observer in the universe, which looks at the universe and his consciousness is confined to a local place inside the brain. And so he interacts locally with the universe, and this creates the experience of classical objects. And he contrasts that with the bird's view, who looks from outside on the universe, where you have no decoherence, where you see the entire entangled state as a single quantum state. And he called that the bird's view. And I think these two perspectives, they are related. I mean, what Wilczek calls the ant's perspective, the temporal perspective of our consciousness in space-time, and contrasted with the God's perspective. The ant's perspective is similar to the bird's perspective in quantum mechanics, and the God's perspective is similar to the bird's perspective in quantum mechanics. So the atemporal perspective is similar to experiencing the universe as an entire total thing, which is a hypothetical perspective, of course. No one who is or whose perspective is realized on just a part of the universe can experience the entire universe.
Yes, of course. But when Max Tegmark talks about the universe as mathematical, is this what he means? That underlying everything, maybe this would be his one, is just mathematics?
Yeah, I'm a little skeptical about that. I mean, he thinks that all mathematical systems somehow generate reality, but I think this is really confusing reality and the model of reality. But I know how he comes there, since this quantum reality is so abstract and so inaccessible by experiment that it's similar in a way to mathematics. It's Platonic in some sense. Plato had this idea, or this conception, that there were ideal things, which get only reflected, and only this reflection is what we experience. So all we experience are just projections of these fundamental ideas, and these fundamental ideas exist in some abstract realm. And I think it's similar with quantum objects with the quantum mechanical wave function, and it's also similar with mathematical ideas.
Mm. But if you take something like Newtonian mechanics, force equals mass times acceleration, something super basic like that, you need a mind to conceive of it, but it's not just made up by the mind, because if there were extraterrestrial intelligences who had developed rocketry to visit our planet, let's say, they had to also figure out force equals mass times acceleration in exactly the same way. So it's out there. I mean, it's a weird thing to even say. It's out there somewhere. It's just, but what is it? It's a description of nature and how it reacts.
Yes, it is. It is. But well, I'm somewhat skeptical that every possible description of nature creates its own universe. And when I say possible, I think actually yes, every description of nature that is physically possible creates the universe. And these are these parallel realities in the average interpretation. But that doesn't mean that every logically consistent description creates its own universe. So I don't think that physics is just the same as mathematics. I think that not everything what one could come up with in mathematics, since mathematical systems they are somehow created artificially. You put up a few axioms, and then the rest of it follows more or less logically. And every single of these systems creates a universe. And if I understand Tigma correctly, this is his ultimate picture. I'm a little more conservative, even if I also say maybe outrageous things. I think I'm not that. I don't go that far.
Well, yeah, but reading your book, it makes me feel like we have a long ways to go in even physics. This idea, well, in the late 19th century, that it's all been worked out to the sixth place after the decimal point and so on. That was obviously not correct. But if you came back, I don't know, 2 centuries from now and look back, would they be saying, oh my God, I can't believe what these physicists were doing in 2023? Now we know, whatever it is, right? Now, of course, we can't do this, but what sorts of experiments are you proposing or models to test that would get at the answer of what the one is?
Yeah. So my main proposal is to rethink the way how we do physics. I think we should think of the foundation of physics, not something that we see in the very small things at very high energies, but that the foundation is the entire quantum universe. So that doesn't mean that I think particle physics is useless or so. I think particle physics is highly relevant. We also, especially, we need particle physics to find out where these problems come from we are encountering right now with this traditional reductionist approach that smaller things are more fundamental than larger things. But it should be complemented with other ideas from quantum information science, from cosmology. And there are ideas and approaches which become increasingly prominent. For example, particle physics are discussing now the idea that the physics of very small objects and very large objects, that they somehow conspire. It's called the buzzword is UV-IR mixing. UV, ultraviolet, is a label for the high energy things, and infrared is a label for the small energy things, and that these things somehow conspire in a way which may explain, for example, why the Higgs particle, which is the quantum of the field, which gives masses to all the other particles, why this is so small, which is one of these puzzles we have in particle physics. Or string theorists now, they are interested in this idea that the universe may be something like a hologram, that and that in last consequence, space and time are not fundamental, and that they can be derived from some fundamental quantum reality. And this, I think, is something which fits perfectly into this philosophy, that there's this one single thing which is purely quantum mechanical, and that we can derive our physics from this thing.
But you addressed earlier in your book the objection, well, all this stuff only applies at the quantum level. Like observing something changes it. Well, if I don't look at the moon, it's still there. So that's at the macro level. None of this has anything to do with the physical reality you and I normally live in.
Well, but I mean, if I'm right, everything is quantum. We just experience it classically. So even big objects are quantum objects, and I mean, I can't prove that this is correct, but my point is that if we adopt this hypothesis, then we can use decoherence and we can understand why big objects, which are quantum objects, appear to us classical. So it's only how things appear that they are classical. It's not that they are classical, in my opinion.
If you were a neutrino, you would think everything is quantum mechanical and not macro.
Yes.
Right.
Definitely. Yeah.
Yeah. Okay. So, back to the intelligent design creationist argument. So that, take the second law of thermodynamics, time, entropy, and all that stuff. How do you get a complex world like ours from a big bang if everything runs down? Where does all that energy and stuff come from in the first place?
Well, yeah. So this is what cosmologists call the past hypothesis, right? So why was entropy so small in the early universe? And well, I think to some extent this theory called inflation can give answers to that. The idea that the universe is expanding increasingly fast. It's actually accelerating all the time, and many models of inflation they predict that inflation doesn't stop. When it started once, it goes on and goes on and goes on, and creating new universes. And this, to some extent, can explain why the entropy in our universe was small at the beginning, since our universe is only a very small patch of this entire universe, which is inflating all the time. Another take on that, which is more related to what I'm thinking about, is that I mean, if time is only entropy anyway, I mean, then there are different states in the universe. Time on the fundamental level is just an illusion. It's just something that our perspective makes out of the universe, and then we have these different possible states, and they exist, and then we can put them just on an axis and call this time. And this is what it is. These are possible states, and so everything which is possible exists. Everything which is physically possible exists.
Mm. So, could there be multiple Big Bangs and multiple universes, and that might be something underlying all that is the one?
Well, if inflation is correct, and I think there are good reasons to be so, then inflation creates a huge number of universes all the time. It's going on in most parts of this multiverse, creating more and more multiverses as ours. But this concept of the one I'm talking about, it's underlying all these. It's more fundamental than the multiverse. So even if you have the multiverse, all these universes, all these possibilities, they are all aspects of this fundamental quantum picture.
And does the concept of eternity factor in here, or infinity maybe is the better word, right? Because you've rejected time. So there's essentially okay, I don't even know what I'm talking about here, but you hear these things like in infinity, there's just as many even numbers as there are whole numbers. And you just go, I don't even know what are you talking about? How can that be? Right. Or, you and I are having this conversation in some other universe, and you and I both have more hair than we do or whatever. Right. and every possible thing that could happen does happen. I don't know. At some point, I just think, this just doesn't gel with the way when I look out the window, that isn't the way the world looks.
Well, yeah, since you are seeing only your universe and which corresponds to your specific perspective on this fundamental reality. So you don't see it all. You just see your perspective. I mean, if you look at at the moon, you can see only one side, right? You can see only the side which is towards the Earth. You can't see the other side.
Well, sure. Okay, so obviously one of the tools of science is to show us stuff that we can't normally see. The germ theory of disease or quantum physics or whatever, the expanding universe. And these are things that we're not equipped by evolution to grasp intuitively. So we use metaphors. It's like this, it's like that. But it's too easy to fall into the trap that it is that. But we have to be careful that, well, it's just like that. The brain is like a mechanical device, or it's like a steam engine, or it's like a quantum computer, it's like a parallel computer, it's like this. Well, it isn't actually any of those. It's its own thing, but its problem is we can't really grasp it. So, it's an information processing computer. Well, I understand what that means, and so maybe that gives me some insight into what my brain is doing, but it's not really that.
Yeah, that's right. I mean, although, of course, if you compare your brain to a computer, you compare two complex systems and you map some properties of one system to properties of the other system, but both properties have a lot of other systems. While in quantum mechanics, we think if we specify a quantum system, we totally know the quantum system. We know everything which can be known about this quantum system. And this is also why some people think that quantum mechanics is just about information, since information is not describing some idealized version which highlights some properties and discards a lot of other properties. But for a quantum system, we really think that we can specify all the information which describes the system.
Are you familiar with the Mysterian Mysteries? This philosophical idea that there's certain things that we can never know, not even in principle, because the structure of our brain is such, or it's only a certain size. Your brain was the size of the Earth or something, you could conceive of a whole different reality or whatever. So it's restricted by language, cognition, and so on. So things like the God question or free will and determinism. There's certain the hard problem of consciousness. Maybe we're just not presenting the problem correctly to answer it, but maybe it's a limitation of human cognition, and it'll never be solved. I don't know. What are your thoughts on that?
Well, it's possible. I mean, it's possible that there are limits to knowledge. Yeah. But why should we give up, right? I think we should try at least. And so far, we were pretty successful with science. And when we hit a barrier and think, okay, maybe our way how we did science so far is not advancing fast enough anymore, then one might think of other ways of doing science. What people have also done in the past. I mean, at some point, it was more promising to think of the sun being the center of the solar system and not the Earth. And at some point, relativity and quantum mechanics were more prominent models to make sense out of the physics of the very fast or the very heavy or the very small. And I mean, I can't exclude that there are limits to knowledge. But so far, well, we are still making progress, and I think there's no point of giving up right now.
Yeah, well, I agree. It's too early in the game. Okay, a couple other things I wanted to ask you about. This letter Albert Einstein wrote to the family of Michele Besso after he died. Now he has departed from this strange world a little ahead of me. That means nothing. For us believing physicists, the distinction between past, present, and future only has the meaning of an illusion, though a persistent one. Is that what you mean when you're talking about time doesn't exist? Yes, what do you think Einstein meant? Is that what Einstein meant?
It pretty well. I mean, Einstein, he also loved the philosophy of Spinoza, and Spinoza is one of the main champions of this philosophy of monism, that all is one. And I think, time is an illusion. The fact that we right now experience only consciously this moment doesn't mean that all the other moments are not there anymore or not there yet. And it is an illusion which Einstein says is made up since we are only part of the universe. We are not the entire universe. We don't see the entire picture.
Yeah. So, but there it feels like your consciousness may continue beyond the death of your body. Like it's an entity in itself without a brain. The mind floats off the brain and it goes off into the quantum field or something like this. And there are attempts, as you know, this sort of quantum consciousness field or area discussion, whatever it is that the brain is like a radio receiver, but the waves are out there somewhere, and consciousness would be something like that.
Well, I think this was mainly Einstein's quote was mainly about the irreality of time, that time is an illusion. About consciousness, as I said, I'm not an expert, but I mean, I think from the fact that our brain appears sometimes conscious and sometimes not, consciousness is something which is related to the way our brain processes information. If we are in a coma, or if we are in deep sleep, we are not really conscious, while if we are awake and talking to each other, we are conscious. So I think consciousness is related to information processing. And then, of course, it makes sense whether this way of information processing can happen only in brains of some highly advanced biological organisms, or whether it can also happen in other systems. I don't know, maybe in robots, or maybe in, I don't know, stones or whatever. I think it's pretty probable that there are other systems which are not human, can have some degree of consciousness. But I don't really understand this picture. You were saying that we are some kind of receiver and things come from elsewhere. So in my in my understanding, but as I said, I'm not an expert on that. Consciousness is something which happens when information is processed in a specific way by a rather complex system.
Or even simpler, it's just a process. And so when you ask, well, where does it go after you die, it would be like asking, well, where was it before you were born? Well, it's nowhere. It doesn't exist. It requires a system, a physical mechanical system operating, and it's the process, the result of the process. Any more than like, well, where does the heartbeat go when your heart stops? Well, it doesn't go anywhere. It's what the organ does. I guess consciousness feels different than what I just said because I don't know. It's a meta level, or it's a second level. I'm aware of my own thoughts or something like that. It feels like I don't feel my brain operating, so it feels like it's its own thing. It's reified as a kind of a stuff, or floating around up there somewhere, even though it doesn't look like that in neuroscience. But we're, again, it may be one of those hard problems because we're conceiving of it incorrectly.
Yeah, it's the only thing we experience somehow.
Right.
Yeah.
Right. Yeah.
Yeah.
It's like the other thing I wanted to ask you about of many things is, why is there something rather than nothing? This argument. Here's how I conceive of it. That it's cognitively challenging because it's not possible for existing beings to imagine not existing, not just themselves existing, which forms the cognitive foundation of afterlife beliefs, but to imagine nothing existing at all. Go ahead and try it. Picture nothing. When I ask myself this question, I start by visualizing dark, empty space bereft of galaxies, stars, and planets, along with molecules and atoms. But this is incorrect, because if there were no universe, there would not only be no matter, there would be no space or time or space-time either. There would be absolutely nothing, including no conscious beings to observe the nothingness. Just nothing. And then I quote Robert Kuhn, and he wrote a book on why this. Let's see, what's the title of his book? Levels of not. Oh, it was why this universe. Oh, many. No, I'm sorry, I'm misquoting the title of his book. Doesn't matter. But here's how he put it. Let's see, not just emptiness, not just blankness, and not just emptiness and blankness forever, but not even the existence of emptiness, and not even the meaning of blankness, and there's no forever. I mean, at some point I'm just using words, and I don't even know what they mean at that point.
Yeah, it's very difficult. Yeah, I agree. But yeah, actually, I think this one may be something similar as this nothingness, and that I mean, if you take parts out of the nothingness, then you have something. Like if you put a hand in front of a light bulb, you see a shadow or something like that. You take a part out of it, but you think you see something. So maybe our world is something like that.
Right. So the one could be, well, we can't conceive of it as a thing, really, because then where did the thing come from and so on. You're talking about something just, I don't know, again, metaphysically, just underlying everything else that's a derivative of that.
Yes. Yeah, it is. Yeah. And to reconstruct it, we can only rely on everything else since we can't really access this one directly. So we have to rely on everything else and try to reconstruct this one out of it.
Right. Kuhn makes this point that if by nothing, you have sort of categories of things that may not exist, including not only physical stuff, but mental, platonic, spiritual, and God. So even in mental, it'd be like abstract or platonic ideas like numbers, logic, forms, propositions, possibilities. Those are words we're using to describe, I don't know what, processes of thinking that would also not exist. So where do those come from in the first place? Maybe there's your one, kind of tying those things together.
Yeah. I mean, yeah, as I said before, I mean, what is the perfect triangle? We don't see a perfect triangle in our surroundings. It's something, some idea we have in our mind, and yeah, in quantum mechanics these things somehow fall together. Since in quantum mechanics we think that the mathematical abstraction is not just some approximation where we throw away a lot of information, but that it's really characterizing what the things are, whatever they are.
Yeah, interesting. Okay, so let's get back to practical things here. If you were the czar of physics and you had $1 billion to allocate for a new particle accelerator or whatever, what should be done to kind of solve the problem that you're addressing in the book?
I don't know. I have no concrete idea.
Really?
I'm kind of happy that I'm not in this situation.
I see, because we're not there to the point. But your book is saying there's a problem in physics. We're stuck. We need to take a different direction. What are you proposing?
Well, I'm more talking about model building, about theory building. That our theories should take these ideas serious. That there's one fundamental thing, and we derive everything from there. And I would suggest that such ideas, as I was talking about before, this UV-IR mixing should be studied in particle physics and try to test that in experiments. Try to test these ideas about emergent spacetimes and string theory with experiments. This is done actually already. There's quite a bit of money in this ideas of it from qubit and so on, where people try to understand matter from the quantum information. Quantum information science. Another thing which I think would be interesting is to look more closely into this connection between consciousness and quantum mechanics. Since if it's really our perspective which creates what we experience, our classical world, then it's quite interesting whether this perspective could change, and whether we could adopt some other perspective, and whether this could change somehow how the world becomes classical. And I think this is a very interesting field which is not really researched on right now, and this would make sense to try changing information processing in our brain and see whether this maybe changes how we experience this this emergence of a classical world from the fundamental quantum world.
You mean emergent properties of nature that don't exist on some lower level but do exist on a higher level?
Right.
Yeah. Yeah, I like that idea. I like that idea a lot. Here's another one for you that I was thinking about reading your book, the fine-tuning problem. Again, how I intersect with these things is dealing with creationists, and in this case, intelligent design creationists, who make this point. And they cite people like Sir Martin Rees's book, Just Six Numbers. And I'll just tee this up for you by giving you these numbers here. So there's omega, the amount of matter in the universe, which is 1. If omega was greater than 1, it would have collapsed long ago. If omega was less than 1, no galaxies would have been formed. And 2, epsilon, how firmly atomic nuclei bind together, which he has at 0.007. If epsilon were even fractionally different, matter could not exist. 3, D, dimensions, which is 3 that we live in, or 4 if you count time. 4 is N, the ratio of the strength of electromagnetism to that of gravity, which is 10 to the power of 39. If N were smaller, the universe would be either too young or too small for life to form. 5, Q, the fabric of the universe, 1 divided by 100,000, whatever that means. If Q were smaller, the universe would be featureless. If Q were larger, the universe would be dominated by giant black holes. And then finally 6, lambda, the cosmological constant or anti-gravity force that is causing the universe to expand at an accelerating rate, which he has at 0.7. If lambda were larger, it would have prevented stars and galaxies from forming, and smaller than so on. Okay, so in reading your book, I was thinking about that. Maybe maybe there's something underlying all those 6 numbers.
Well, this argument goes a little bit into this what physicists call an entropic argument, that if things would be different, then we wouldn't be there to observe the universe, and then one could think of some metaphysical concept like intelligent design somehow creating the world in exactly this way, which to me is not very satisfying. And other people think about the idea that inspired by these different universes which pop up in this early process of cosmic inflation, so that you have a multiverse of different universes that where maybe 99.999% of the universes, they don't allow for intelligent beings. But we, of course, have to be in a universe which allows for intelligent beings. And this is the explanation why we observe a universe which allows for intelligent beings. And I think the second argument is okay to some extent. Of course, a fish wouldn't be surprised that he finds himself in water, since if he would be in water, he could think about why he is in water. But on a more fundamental level, this is not why the ocean is there, right? I mean, there are reasons why the ocean are there. The size of the Earth has enough gravity to keep the water there. The temperature is in the right range to allow for liquid water and so on. There are more fundamental explanations why the ocean is there, and I like to look for these more fundamental explanations. And I think I think whether some some quantity is more or less in the right range that it allows life. This could be explained as with these many universes and so on. But if something is very 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 improbable, like the mass of the Higgs boson, which is so much lighter than the usually expected scale, which is the scale where quantum gravity becomes large, or the size of the cosmological constant, which is even much more improbable. If one would calculate it from quantum processes, it would be much larger. Then I think, well, maybe there's some deeper explanation behind it, and we can understand that. And yeah, I mean, if this unifying concept, this one, contains everything which is allowed, then yeah, it also says what's not allowed. And maybe this is also where I do not agree with Tegmark. I think physics is probably more constrained than just every logical consistent system. And so that at least some of these fundamental questions we can explain if we would know the fundamental theory.
Yeah. Right. So when I present intelligent design theorists with the multiverse idea as an explanation for the fine tuning, and then they say, well, how do you know that's true? That's just your faith. There's no evidence of multiverses. But I'm told by people like you, physicists, that it's not just a made-up hand wave, that it's a derivative of the mathematical equations or whatever.
Yes. Yeah. It's not something we can directly probe experimentally, but it's something that we can infer if we take the theories which have consequences that we can probe experimentally, are extrapolated to some realms where they can't be probed anymore. So it's something which follows from the theories. It's a consequence that we can't test, but there are other consequences of these theories that we can test, which makes us somehow confident that these other consequences also exist.
But even if our universe is the only one, and we do have these numbers, are you saying that it doesn't necessarily suggest there has to be a tuner, a fine tuner that tuned the universe, the designer, but that this underlying principle could account for it? We just don't know enough yet to say one way or the other.
Yes, of course. I mean, even if the universe would be fine-tuned for life, that doesn't mean that there's some consciousness behind or some good willing agency or whatever. I mean, it could just be that there are some physical laws which are fine-tuned that way, or maybe they are not fine-tuned, and what appears to be fine-tuned just looks fine-tuned since we don't really understand the full framework. I mean, this is my favorite idea. Like if you see a pencil balanced on the tip, it looks very fine-tuned. But then if you look, there's a hand holding it, then you understand there's some principle behind. It doesn't have to be a hand. It can be just some device holding it in this position, and this explains the thing.
Is this what Einstein meant when he said he believes in Spinoza's God, which is basically just the laws of nature? Whatever it is underlying the whole thing, yeah, I believe in that.
I think so, yes.
But of course, for most people, they want more than that. You know, they want a personal God, an agent, a being that knows we're here and so forth. Is there any room for that in your model?
I don't know. I'm rather skeptical since okay, as I said, this again brings up the question about consciousness, and I'm a physicist. I'm no expert on consciousness, but I would think that requisite for consciousness is, for example, time. And if this very fundamental reality is timeless, I think then it makes no sense to think that it is conscious. I think consciousness should be a process in time, and without time, I cannot think about consciousness. But I don't know, maybe, but for me it's difficult to imagine.
I don't know if you've looked into Roger Penrose and Stuart Hameroff's theory about consciousness, which they relate to quantum coherence. I think they talk about decoherence and coherence at the subatomic level inside neurons. So if I understand this correctly, inside our neurons are these little microtubules that are like scaffolding that hold the cells together. And inside there, you could have quantum effects. Now, the initial response to this theory was quantum effects can't happen in a warm, wet environment like a brain. But now I'm told that that's not true. That quantum effects can happen at a, like in plants or whatever, at a warm, mushy environment. So their idea is, again, if I understand it correctly, as the wave functions are collapsing inside these quantum effects inside neurons, it causes the neurons to kind of fire in some sort of synchronous way, and out of that kind of synchronicity of billions of neurons firing together, you get something like a conscious state.
Yeah, I think it's still debated whether neurons can be in a quantum state or how this can be realized. But from my point of view, I think this idea goes somewhat into the wrong direction, since it tries to explain something extraordinary, that some matter can be conscious by invoking quantum mechanics. But my view of quantum mechanics is that quantum mechanics is not something extraordinary, but that every system is a quantum system. It's not something special which only microscopic things, some special property which only microscopic things have, or some special collection of matter. But that quantum mechanics is really ubiquitous, and the thing is that we just don't experience it, since we have a specific perspective on the whole thing. And but if everything is quantum mechanical, then this is not a good explanation for matter to behave in some extraordinary ways.
Mm. Yeah, if you just look at like the Wikipedia page on the hard problem of consciousness, there's like 24 different theories, and no one agrees what the right one is. So to me, again, I just look at that and go, okay, it's probably early on in the game. Maybe we're misconceiving of how to even ask the question, much less answer it. I don't know. Again, it's my favorite argument for why I like to be chronically frozen and come back in a few centuries and go, oh, that's the explanation. Oh, sort of like how we look back at Newton's time or whatever. Right. So
yeah. It's almost sure that in 100 years people will know more than we do today.
Yes, of course. But not just more stuff of the same kind of category, more information, but actually a completely different conception of how you try to address the problem.
Yeah, I'm sure that would be the case.
Yeah. All right, Heinrich, I got to kind of wrap things up here with a heart out myself, but I just wanted to ask you a couple other questions. Are we living in a matrix? This argument that maybe this whole thing is a simulation, if information processing and mathematics is true.
Good question. Well, as I said, on the quantum level, actually, the relationship between information and reality becomes somewhat blurry, since we think that if we have a quantum system and an electron, we can perfectly describe it with a few numbers. And this information contains everything which there is to know about the quantum system, and we can use this information to teleport the quantum system somewhere else. So I think it's a very difficult and fundamental question how matter and information are related on the very fundamental level. And it might be that everything is somehow information realized, and then we might live in some kind of matrix. I'm not sure whether we are living in a matrix which was created by some alien somehow, but what we know about the world is what we have in our consciousness. And if our consciousness is just processed information, then everything we know about the world is processed information. And so, in some sense, we always live in a matrix.
It's all a matrix because it's all in our head, right?
Yeah.
Again, we're back to Deepak. This is what he says, right? Where is the red? If you open up your skull, there's no red in there. Where's the Milky Way galaxy? It's not in there. It's just information. Okay, that is a kind of matrix, right? That's really funny. And yet, if you look out the window, there's no buffering, or there's it's pixelated, and then it comes clear because the computer had a little glitch in it. I mean, as I understand the kind of simulation hypothesis, somewhere down the line, there has to be a hardware system running it.
Yeah. I think so. But then again, I mean, to have matter, if I'm correct and the quantum mechanical reality is the most fundamental reality, then matter itself is also emergent. And it is created by our perspective on the universe, and the perspective again is created by our consciousness, which is information, and the information again is somehow encoded in matter. So it's some kind of chicken egg problem, and I don't really have the answer to that. So maybe these things somehow emerge together in some loopy process or something like that. But well, it's speculation.
Yes, it's like science fiction. So that's one of my favorite episodes of Star Trek: The Next Generation. Ship in a Bottle, it was called, where they go on the holodeck and they're playing the game with the Sherlock Holmes. Moriarty is the enemy, or they got the whole thing going. And then all of a sudden, Moriarty leaves the holodeck. He goes out into the Enterprise, and they're like, "How can this be? He doesn't exist except in the holodeck. It's just an information program." Right. So the rest of the episode, they're trying to figure out how he pulled this off. And then at the end, they realize that they're still in the holodeck. He never left the holodeck. The holodeck itself created an enterprise that was not really existing. Right. And they figured this out because one of the characters who's left-handed is all of a sudden right-handed, or vice versa, or whatever. There was some little glitch, right? That wasn't quite right.
That's cute. But of course, it triggers the question whether the original Enterprise also is in the holodeck.
Right. Yes, exactly. Right. So, but and then the show ends with there's like a little cube, and it's like all of that is happening in that little cube right there. and then then one of the other characters says, maybe we're in somebody's cube somewhere. But if okay, so just the last point here. If there's no way to know, then we're not doing science anymore, right? If it's not even in principle possible to know, then we're just having fun.
I agree, yes. But on the other hand, to do science, we always need to speculate, right? We always
that's all good.
Beyond what we know and make up theories, and these theories may be wrong or right, but it's an important part of science to speculate.
Definitely. All right, Heinrich, thanks so much for coming on to talk to me about your new book. Congratulations on the book. I really loved it. Super interesting and fun. What's next on your research writing agenda? What are you working on?
Well, I want to try now to somehow condense these ideas, these more philosophical, metaphysical ideas into some ways how to inspire my research. I mean, I'm a phenomenologist by education and by expertise, so I work with neutrinos, and I want to try to use neutrinos to understand more about quantum physics. I'm highly interested in this idea of UV-IR mixing, this mixing of the very small physics and the very large, the physics of the very small and the physics of the very large. And I want to think to make these things more concrete, and maybe in a few years I can tell you more about your billion-dollar question, what I would do
okay.
with the money in which experiment.
Okay. We'll have you back on the show when you figure that out.
Okay.
All right, Heinrich. Thanks so much.
Thank you very much. Yeah.